So I landed in the London airport yesterday, and I ran into an old school friend of mine. And we hadn't met for a long time, 15 or so years. And he asked me, "What have you been up to?" I said, "I've been busy innovating with AI." He said, "That's not possible." I said, "What do you mean? It makes no sense." He says, "Because AI is not in San Francisco." I said, "That makes no sense." So he takes out his iPhone, opens up his playlist, and there's AI. AI is a music band. So AI means different things to different people, to different companies. And I'm here to talk about what AI means from an industrial IoT perspective. At this event, you're going to hear about how different companies are using AI. This is very much focused from an industrial perspective. Imagine planes that self-maintain themselves. Imagine all the data that gets generated by the planes if we are able to mine through it and generate insights to prevent any part failure so that there is no flight delays. Imagine locomotives that are optimized for fuel efficiency, that self-optimize based on the wear and tear of its individual parts, but also under the weather conditions it's operating under. Imagine street lights that are smart enough to be just as bright as needed, depending on the humans or moving objects around it. Imagine healthcare equipment that talk to each other, so that when you go in for an X-ray or an MRI scan, it's able to connect across the globe and find the best cure based on your X-ray. Imagine wind turbine blades that adjust the blade angle and speed depending on the natural speed and angle of the wind, natural spin and direction of the wind to capture the most efficient energy. Not going to spend a lot of time talking about GE, but wanted to give you a brief sense of what of the industries we cover. At its heart, we are a big iron company. We do manufacturing and servicing of huge equipments, right from aircraft engines, jet engines, to locomotives, subsea equipment, MRI machines, X-ray machines, wind turbines, gas turbines. So traditionally, industrial companies have not focused so much on software, or the software has primarily been used for back office IT operations. Software has not been a differentiating factor in their strategy. But it's now with the industrial internet that software and analytics and AI is coming to the forefront and becoming a competitive differentiator for industrial companies. Just to give you a sense of impact that industrial IoT drives, GE generates half of the world's electricity on a daily basis. Every 2 seconds, a GE-powered aircraft takes off. 3,000 healthcare equipments are used across the world to save lives every day. The Industrial Revolution in the 19th century that started here and spread out globally changed lives, changed economies. It changed how manufacturing is done. It changed how we work. We believe a similar revolution is happening now with the industrial internet as machines get connected and smarter. So what is the industrial internet or industrial IoT? 3 decades ago, when 1 billion people connected online, the term consumer internet was coined. It speaks to the phenomenal transformation and disruption we have seen in the consumer space, whether it be media or retail or e-commerce or advertising. We believe a similar revolution is happening now with the industrial internet as 50 billion machines get connected over the next decade. Industrial internet refers to a connected network of intelligent machines working smartly together. So what's the difference between the consumer internet and the industrial internet? If you are not able to log in to your Twitter account or your Facebook account, you get annoyed. If all the power in this building goes off, you get angry or fearful, or if it's in a hospital, people could die. So reliability is crucial in the industrial internet. So too is security. A jet engine has to be utterly impervious to security breaches, even as it is transmitting data to a secure destination. The third factor is durability. Our machines last for two or more decades. So we're talking about software with a lifespan that might seem absurd in the consumer space. The industrial internet also grows at twice the speed of the consumer internet in terms of connected machines and data that's collected from sensors. So let me give you a sense of data. We all know about big data from the consumer space, whether it is social media, weblogs, or pictures, or images and videos and such. What does industrial big data look like? This is data that's captured from the sensors of a jet engine. In the past, just a decade ago, the engines could capture 3 snapshots of data of up to 50 sensors. 3 snapshots, irrespective of whether it was a 1-hour flight or a 14-hour flight. Once during takeoff, once during climb, and once during cruise. With the newer engines, we are able to capture data at the rate of 1/16th of a second, and up to 5,000 parameters or 5,000 sensors. So you can imagine the sheer volume of data if it is a 14-hour flight. And that's just from a jet engine perspective, but we have such industrial-grade machines across the world, whether it is wind turbines or locomotives or subsea equipment, and all of them are capturing data at such huge volumes. But that's just the volume of the data. Now think of the variety of data we have. We take our machines from cradle to grave. So we design our engines, we manufacture them, we service them, and we retire them. So we have design images, engineering drawings, manufacturing floor, factory, time series data. We have service records, quality, and reliability records. The variety of data that an industrial company has pretty much covers the whole spectrum. The last point I want to make about this is more on big data or AI came more to the forefront in the past few years as consumer internet took off, as social media took off. Now, if you look back at a company like GE, we were founded in 1892. We're looking at data that's not just decades old, but is centuries old. We have design images from in the last century. So how do we store, manage, and use this data? The traditional data storage systems just don't work. They are too rigid, too slow, too expensive. Companies are putting together data lakes as a way to manage and store data at an enterprise level. The idea is simple, that you get the data in its raw native format and keep it all in one place, make it available to everybody in the organization for faster access to solve business problems faster. The fundamental assumption it makes is that everybody who uses the data knows the data quality issues, understands how to join and merge and blend the data, and understands the sources of data, right? Because data lakes is just trying to solve the challenge around data silos. But at the scale at which we operate, that just doesn't work because it's almost impossible to train somebody the nuances of every data element. Unless you're a data scientist or an engineer who is very hands-on with the data, you cannot train that person. So with that in mind, I don't know if you've heard of the term, but there's data janitors or data engineers who we focused on building out a consumption layer on top of the data lake so that no matter who is accessing the data, whether it's a business analyst or an app or a data scientist, they're all accessing the underlying data, but the consumption layer does all the dirty work for them of cleaning, blending, and making the data available easily for consumption. Let me give you an example of what I mean by that. Can all of you read this slide? I bet even if you could read this slide, it probably doesn't make much sense to you. So these are some of the parameters that come in from a jet engine, the one I was talking about earlier, every 1/16th of a second. In fact, it doesn't even come in like this. It comes in just as a massive time series of numbers, just numbers. The first obvious step is to put some kind of column headers or tag it in a way so that you can at least understand it, right? But even then, it's not that useful. Now imagine as this data is flowing in from a jet engine, if you're able to get all the metadata around this engine. If you're able to get the metadata around all this industrial asset, when was this engine manufactured? How many service visits has it been to? Where does it usually fly? Has it had any major issues? Where was its last flight to? Imagine having all the metadata around the engine as the time series data flows in. That's the real power. And we're focused on putting the context behind every asset to make that time series data more useful. Are there any pilots in the room? So I actually can fly planes. Of course, not the massive planes that these would be on, but small plane. But when I saw the column headers for the first time, some of them made sense to me right away. I could even visualize a dial on my small plane. But imagine if we are successful at putting context around every asset, a non-pilot should be able to see the data and say that, oh, this doesn't make sense, this is not in the range of values, or this is what it should be, right? So that's what context is about. It's about making the user very aware of all the metadata around it. So AI has come to the forefront again in the past few years. AI has been going through these cycles of hype. If you look at it, there's been a lot of hype around what AI can do. There's investment, there is overpromise, there's investment, there's underdelivery, and the investment drops. We saw it in the 80s, and now we're seeing it again. But this time around, there is much more technology advances, right? Both in terms of infrastructure, cheaper storage, scalability. I think we are able to do bigger and bolder development with AI compared to the 80s or before that. In the consumer space, if your algorithm doesn't work, it results in a bad social media experience. If your analytic predicts something wrong, it results in a wrong ad being displayed, or worse, your shopping cart crashes. In the industrial space, if an algorithm that's predicting when an engine might fail, and if it doesn't work well, it results in flight delays. If it's an algorithm that's predicting when an X-ray machine part might fail and it doesn't work, it results in patient delays. So the impact is much larger if from an industrial perspective, if your algorithms are not accurate. AI in the factories. I'm going to talk about AI from two perspectives, from the factories and from servicing perspective. When we think about AI in the factories, we primarily think of robots, right? That's the image that comes to mind, is robots running a factory floor. Let me take a step back and explain how I think about AI. There are three levels of AI: artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. Narrow intelligence is a form of AI which can do a narrow task that it's asked to do, that a human can do. It may do it better than the human, but it's very focused on one specific task. General intelligence is a form of AI where it's able to do everything that one human is able to do, irrespective of how many of our tasks. Super intelligent is a combination of all the smartness across all the humans and building the smartness which is smarter than every human in the world. Super intelligence is really when the machines are smarter than the humans. Today, when we talk about AI, whether it's in the consumer space or the industrial space, we are primarily talking about artificial narrow intelligence. Today, we are able to automate tasks on the factory floor to actually do the tasks that a human would have done, but it's very tedious and repetitive. In field services, today we are able to look through petabytes of data and able to predict when a power grid might fail, and then proactively send a field service engineer to fix it so that there is no power failure. Today, the same thing, whether it's a jet engine or a locomotive, today we are able to predict and send a human to go and fix it, right? But tomorrow, when artificial general intelligence becomes more common, or super intelligence comes into play, do we see self-healing power grids? Do we see power systems that self-maintain themselves and not just without any human intervention? But true super intelligence is at a point where the engines design that next version of the engine. Removes the human completely from the loop is when the power grid is able to see all the history of everything that has happened and be able to design that next version of the power grid. Today we are not at that point because I think there's still technological advances that need to be done. The human brain is incredibly complex. What is simple and easy for us to do is very difficult to program. It's not as easy as that. Even with the software and analytic techniques that exist today, we're not able to mimic our brains. We are not able to actually do everything that even a human can do, whether it is automated tasks or whether it is creativity. AI is still in its infancy in the industrial world. But when AI takes off, when we start seeing super intelligence come into play, can you imagine that world? Can you imagine the world where machines are smarter than the smartest human beings? Whatever it is, I truly believe that AI is going to have the biggest impact in the industrial IoT world, whether it is reducing power consumption, improving our lives, changing the way we live. These are big outcomes, some of the biggest outcomes that AI can drive. Thank you.